Alrighty. I want you to hold up your graphs. And then don't erase. I'm going to grab a couple to talk about, but we're going to talk about a few of them. I love. Okay. Carla, I'm stealing yours. Don't erase your graph because we might talk about yours in a minute. I want you to look at these two parabolas. What's different about them?
They both go through the
They do both go through the X. That is something they have the same. What's something different? One's upside down, one's right side up, right? If I was looking at an equation for these, what would that look like on the equation? How could I tell if it's smiley face and frowny face? Positive or negative. The first piece, our A value. If our A value is positive, which way is it going?
Up.
Up. Happy face. Positive news makes us happy. Happy makes us smile. Positive A values give a smiley face parabola. How about for the downy ones? What would that be? Negative, because bad news makes us frown. Frowny face parabola goes upside down. Okay. Show me your parabola again. Alright. Let's see. Alright, yes, we have upside down and right side up. What else do we have?
No x-intercepts?
I was going to say, well, we do have x-intercepts, but how many x-intercepts do we have?
One.
One. Each of these has only one. So the x-intercept is at what point?
The vertex.
The vertex. So our vertex and our x-intercepts are the same thing here, and that's okay. Okay? So this is going to be a do we remember from Algebra 2 situation. If I look at this one, and that's a positive, let's pretend that's a 5. And I want to put this in vertex form, it's going to be x what? Minus 5 or plus 5? Over here, for it to switch to the right.
Minus.
X minus. Because inside those parentheses, it's got those opposite signs. If it said x plus 5, that would be this guy over here on the negative side. We're going to practice with this, but I just kind of touching through stuff. All right, one more. Hold up your parabolas. One thing I'm going to do. Okay. Good. Okay. That's okay. We'll talk about it. The other thing I want to point out. You know what? Oh my God. Real quick. Just because there's one thing I want us to talk about. If we have a parabola that looks like this. Okay, well, a little less wonky. That number right here on our y-axis is in one of those equations as well. And we'll talk about specifically which one in a minute. But it is the difference between here and here. The parabolas are almost the same, it's just one's been scooched up and one's been scooched down. So that is just a C change. So we're going to look at our C values on that one. So what we're going to do is we're going to talk through these forms and what they mean and where we'd find all these pieces. And then we're going to do the card sorting activity thingy. All right? And I know this is not a page that you guys have in your book to write down. We're going to talk through it. You guys are going to work with it. But I'm going to write things down. That way, if you need to, you can pull it up online. I'll put the PDF up. So we are going to see what pieces from each of these forms we find. So the easiest one to think about up here is probably our vertex form. What important information about our graph will our vertex form tell us? The vertex. Woo, chunky pen. There we go. The vertex. We find our vertex inside at H and K. The formula's up here. The vertex is at the point H, comma, K. So specifically, this one's vertex is where? 5, -1. Is this a happy face or a frowny face parabola? Right, up or down? Up. So I could, from this equation alone, be able to tell you, all right, there's my vertex. It's going to be up face. It's going to look kind of like that. I can give you a little bitty sketch. From here, I know this guy's at 5, comma, -1. What about factored form? What's that going to tell us? Our x-intercepts. So where it crosses that x-axis. I'm just saying, for as many people that mentioned in their homeworks derivatives, I'm having very few people actually participate. Because apparently we're doing so well with our quadratics, we're accidentally calculusing. Everyone who mentioned derivative in the homework, you didn't get points for that one unless you can tell me what a derivative is. Uh-huh. Because that's a calculus thing, y'all. I was going to say, there's, I think, one person in here who could have made that argument, and they didn't put it in there. Just say it. There's only one person I know of in here who actually has taken calculus. All right, so our x-intercepts, that's going to be where it crosses our x-axis. So looking at these ones specifically, where are our x-intercepts in this equation? 4 and 6. Positive 4, positive 6. 4, comma 0. 6, comma 0. It's always going to have the opposite sign because our formula has a minus sign in it. Is this an upwards opening parabola or a downwards opening parabola? Up. It's a smiley face. Positive A value means we are a happy face. Goes like that. Our last one, probably our most subtle piece here from our standard form. What information can we see from our standard form? Without having to factor it, without trying to do anything like that. This one's a can you remember from Algebra 2 because it really doesn't come up all that often. It's this guy right here. If x is 0, 0 squared is 0. Minus 10 times 0 is 0. So if x is 0, y is 24. This guy is going to be your y-intercept. When x is 0, my y is 24 here. And then again, this is a happy face parabola. It's going to look something like that. So we have information here, lots of information, but it all comes in different ways. So what we're going to be doing today is we're going to be working with one of those little card thingies. I know, everybody's favorites. So I'm going to pass out, every group needs a set of pink cards. And I want you to find A, H, and E, and we'll talk through it. Dominique, I'm going to have you look over the soup now, just so you guys don't have to worry about it. Find your A, H, and E cards so I can walk you through what we do.
But don't they take like
Find A, H, and E. A, H, and E, the cards. They have an in the top corner over here. A, H, and E.
oh, that's the actual card.
Because I'm going to walk you through setting them up. Because unless you've played the game Dominoes recently, it's weird. So what you're going to do is you are going to put H in the middle. A and E, oh, that almost worked perfectly. I was about to be really impressed with myself. A and E go on either side of it, and you're going to have to figure out how. Do the graph, the graph on this card will match up with the equations on this card. Or the graph on this card will match up to the equations on that card. So whatever equations are on the card do not match the graph on the card. You've got to match them up like this. Okay? So H is in the middle and A and E go on either side. So looking at the picture on H, what do you see about it? What do we notice in that picture? It's a brown, which means what can I tell about the equations?
It's negative.
They're going to have a negative in front. So looking at my two cards here, which one of these is going to match up with the picture on H?
E.
E is. We can also see that it's got our factors there. We can also look at our factored form. It also matches. You can also look at our standard form. Has about an intercept of about 16. That looks great. It's got the vertex there. So E is going to go with the picture on H. A is going to go, that's,
E's
Yeah.
gonna go with it.
there we go. I was holding this one upside down. So this picture matches up with these equations. This picture is going to match up with these equations because I told you those go on either side. Okay? What you're going to do now is you're going to take the rest of the cards and you're going to connect them in a circle. This is going to make one big donut or square or railroad track, however you want to do it, of information. Some of the cards are missing pieces of the equation. You have enough information there to be able to match them up. So do the thing. Okay? Match them up. Work with your partner, check with your stuff there, match them up. Okay?